Assalamu alaikum students, this is Farwa Batool, your O-level computer science instructor, and welcome to another video on the topic of identifying errors in algorithm. Here I need to mention one thing. Please, if you haven't seen my two previous videos on this topic, first of all, it's very important to go and see those videos because this video is connected to those. Now, the first thing here, we are talking about this worked example of your book in which we have a flow chart to find the maximum and the minimum number in the list of 10 numbers. So what we have seen in the previous videos that this particular flow chart where you are setting the range, the variable b is initialized with 0 and c with 100. There is a drawback of this design. Here, if your test data values are less than 0, all are negative, or are greater than 100, all are greater than 100, then the result will be incorrect. You will either be unable to find out the highest value or the lowest value in your test data. If you don't understand my words, please go ahead and watch the previous videos in which we talked about this in detail. Now look at a better algorithm. This flowchart is transformed and is turned into a better solution. Look at here. Now the range for the highest and the lowest numbers to be identified is changed. Here variable b is initialized with minus 1 0 0 0 0 0 0. It's a very much negative number or a very small number. And c is initialized with a very much larger number 1 0 0 0 0 0 0 then 100. So here the range of the test data is increased. Now all the numbers that are within this range will be incorporated and will give us the right result. But again, the problem is in this range. If your test data is going to be below the number that you set in variable b, then result will be incorrect. And if the values of the test data are all greater than the value in variable c, then your result will be incorrect. Again, the same problem will be there that if the test data is not within this range, this flowchart will fail to identify the highest and the smallest numbers. We have already seen this in detail in the previous video. Now, here is a much better algorithm for you. What you have done here is, look at here. When you start the flowchart, first thing you did is initialize the variable a with 0. A is basically used to monitor the number of iterations. That's why it is 0. Now, you got first number as your input. This is the input of the user. The user is going to give us 10 numbers in which we have to find out the highest and the smallest number. So the first number you have taken as an input by the user out of your loop, and you set both of these variables b and c with your first input. Let's suppose the first number the user gives as an input is 2. So what you do, you are going to set both the variables b and c with this first input. The first input is going to be assigned to both the variables. And then your loop is going to start. And within the loop, you will be getting all other 9 numbers. Since there are 9 numbers that you are getting in the loop one by one, that's why the iteration here is going to be 9 iterations in total. Now it's no more 10 iterations because earlier we were getting all the 10 numbers inside the loop. But now in the better algorithm, much better algorithm. We are getting one input out of our loop and we are setting that value of our input number in variable B and C, and all other 9 numbers are in the loop. So that's why now the iterations are not 10. Iterations are going to be 9. And you will be comparing the same way. X is your input value. You will compare it with the values in variables C, B, and C. In the first iteration, it will be very interesting. What? In the first iteration, you are going to take your second number as your input. Let's suppose, let me clear this for you. I'm erasing this all and making this thing clear. Look at here. Let's suppose the list of number starts from 2, 3, 7, and so on. Let's suppose these are my numbers in the list. 2 is already been set in variable B and C. And when you going to start your iterations, now here the input will start with the second value of your list, or second value of your input data. So here the X is going to be 3 for the first time. And then when you will be comparing these two conditions, so automatically you are going to compare the value of X, which is 3, with the first value of your input, which is 2, because B and C, remember that these are set as the first value of your input. So 3 less than 2 and 3 greater than 2. So these two conditions are basically in the first iteration. You are comparing the first number of your list and the second number of your list. And in the third iteration, we will move this way. So there is no need to initialize variable B and C with some other value. It's a very good solution that you are initializing it with the first number in your list of inputs, and then you are comparing it with the other numbers in the list. Now we will see that if it is going to work for all of the values or not. Look at here. The activity says that activity 7.17, rewrite the pseudocode so it works for every set of numbers like the flowchart above. Test your pseudocode algorithm with this set of test data. Now we have to test the flowchart. But before that, we need to convert the flowchart into pseudocode. Look at here. This is basically the pseudocode of your worked example in which the variable B and C was initialized with 0 and 100. But if we convert a much better algorithm into pseudocode, the line of code will change. What we will be doing here, look at here, it is very important. The first thing we will do is assigning the value 0 to variable A. Next, we are not going to assign any value in variable B and C. We are going to take input from the user, and to take the input, you will give a message to the user. Enter your 10 values. Next thing what you will do, you will write down input X, which means you are getting the first number of user's input and saving it in variable X. Now what you will do, you will assign variable B and C with that input data, the first number that user gives as an input. This is what you have to do. After assigning the first input to the variable B and C, now you will start your repeat until loop. Now everything will be same, but remember that since we are now going to take 9 numbers as input, so the iteration is going to be less than 9. It will be from 0 till, we will check 0 till 8. They are going to be total 9 iterations in the loop. So if the value of A becomes 9, then we will go out of the loop. We only need 9 iterations to work on, as we are taking only 9 inputs in the loop. We are not taking 10 inputs, all the 10 inputs like we did previously. The first input is already been taken before the loop and it is assigned to the variable B and C. Now do it the same way. If X is greater than B, then what you will be doing? B will be assigned the value of X. Here it is and if. I'm just copying all other line of code. The other condition is if X is less than C, then C will be assigned the value of X. Now, finally, this is and if. Here it is very important, you are incrementing the value of A plus 1, and you will check until A is equal to 9. If the value of A becomes 9, you will go out of your loop and then you will output the values of variable B and C. This is the pseudocode for the much better algorithm. Now, we need to work on it and we will see that how this test data will work with this pseudocode. Is it going to give us the right result or not? Let's see that. Okay, so I made it a little clear for you. Now let's start working on this new pseudocode for your much better algorithm. We have the test data here that starts with minus 97 as your first input. Okay, so look at here. Variable A is initialized with 0. Let's put 0 in the column of A. Then you have an output message, enter your 10 values. This statement, input X, means that you are going to save the first value of your input, which is minus 97, in variable X. So let's just write down minus 97 in column X here. Next, we are assigning the first value to both the variables B and C. So let's write down minus 97 in variable B and minus 97 in variable C. Okay, this is done. Now let's start our loop. This is the repeat until loop. Remember that inside your loop, there is the first statement, input X. This is basically going to save the second value of your test data in variable X. So here X is equal to 12390. So let's put this in the column of X. 12390, which is the second value of your input data. Now we will be comparing the value of B and C with the new value of X, or the second input. Is 12390 greater than minus 97? Sorry for this handwriting, sometimes it becomes a little weird. 1, 2, 3, 90. Yes, this value is greater than minus 97. Since the condition is true, you are going to assign 12390 in variable b. Let's modify variable b 12390 as the condition is true. Now let's see the next condition. In the next condition, if 12390 is less than minus 97. No, it is not less than minus 97. Condition is false. No need to change variable c. Go down and increment the value of a. It will be 0 plus 1, which is 1 now. Change it to 1 and go down. See if the value of a is 9. No, it is not 9. Go and do working for the next iteration. Okay, so the next value we have is 0. Now 0 is going to be saved in variable x. Put it in your trace table. Now compare the value of b and c with x. Value of b x is 0. Is 0 greater than 12390? No, this is false. No need to go here. Go down and check for the next iteration. Sorry, next condition. X, which is 0 less than the value of c, which is minus 97. Look at here. C has a value minus 97. 0 is not less than minus 97. Again, no need to change the value for c. What you will do, you will increment the value of a. A has a value 1. Now 1 plus 1 will become 2. Write down 2 in the column of A and check for the until condition. Until condition is false. A is not 9. A is 2 right now. So we will go up and do working for next iteration. So the next value of your test data is 77. Put the value in variable x 77. Now compare, is 77 greater than the value of b, which is 12390? No, this is false. No need to change variable b. Now, is 77 less than minus 97? This is also false. No need to change variable c. Go down and increment the value of a. A had a value 2. 2 plus 1 is 3 now. So first write down the value of x 77 and then increment a. No need to change b and c in this iteration. Go down, check for until condition. The condition is false. Why? Because a is 3, a is not 9. So you will go up and you will do working for next iteration. The next number that I have is 359. Let's save it in variable x. Compare 359 with the value of variable b, which is 12390. 359 is not greater than 12390, which is a very big number. No need to change b. Compare it with c. 359. Is it less than minus 97? No. No need to change variable c. Go down, increment a. 3 plus 1. It is 4 now. Just write down 359 in column X and write down 4 in column A. Still, the until condition is not satisfied. Go up and do the working for next value. The next value we have is minus 2. Minus 2 will be saved in X. Then, is minus 2 greater than 12390? False. No need to change b. Now look at here. Is minus 2 less than minus 97? No, it is not less than minus 97 because it is a less negative number than this one. So no need to change c. Go down and increment the value of a, which will be 5 now. Write down minus 2 in column X Write down 5 in column A. Condition, until condition is false, go up and do for the next value. The next value we have minus 2, then minus 89. Put minus 89 in X. Then is minus 89 greater than 12390? False. Is minus 89 less than minus 97? False. Because minus 89 is greater than minus 97. No need to do this. Increment the value of A, which will be 6 now. 5 plus 1, 6. Let's put 6 in column A and put minus 89 in X. Now, check for the until condition. It is not satisfied. Go up and do working for the next iteration. The next value we need to work on is 5000. Let's put 5000 in variable X. Okay. Now, is 5000 greater than 12390? Wrong. It's not greater than this. No need to change. B. Is 5000 less than minus 97? No. So, no need to change value of C. Go down, increment A. A will be 7 now. 6 plus 1 is 7. Write down 7 in your table. Do working for the next iteration as the until condition is false. The next value we have is 21. Write down 21 in X. Is 21 greater than 12390? No, no need to change. B. Is 123, is 21 less than minus 97? This is also false. No need to change any variable. Increment the value of A. It will be 7 plus 1, which is 8. Write down 8 in column A. Since the condition is false, no need to go out of your loop. Let's do for the last iteration. Okay, look at the last value, which is 67. Write down 67 in column X. Now comparing 67 with value of B, which is 12390. 67 is not greater than 12390. No need to change the value of B. Next is 67 less than minus 97? No, this is also false. No need to change variable C. Now increment A. A will be 9 now. 8 plus 1 is 9. Now when you are going to check for your until condition, it will be satisfied. It is true now. Yes, the value of A is 9 and there is no more numbers left in our test data. So when we go out of the loop, we will see the values of B and C. B must have the highest number of our test data and C must have the smallest number of our test data. So look at here. The value of B is 12390 and the value of C is minus 97. So this is what is expected. Yes, these are the correct values for the highest and the smallest number in our test data. Manually, if we see that 12390 is the highest number that is identified by the pseudocode and minus 97 is the smallest number that is identified by this pseudocode. So this pseudocode is going to work for all type of test data, all type of numbers, either they are negative, positive, regardless of any limit. It's a very good solution for the given example to find out the highest and the lowest numbers in the list of numbers. Stay tuned, stay connected. Do not forget to subscribe the channel. In the next video, we will be doing another topic for you. Bye bye.